Betelgeuse, the galaxy's largest and most stunning star, rested on the shoulder of Orion like a guardian of space. It has been watched by people for millennia in wonder and curiosity. Its vivid red blaze and recent mysterious periods of fading have contributed only to the mystery. As a red supergiant nearing the end of life, Betelgeuse will explode in a brilliant supernova blast. But when this star phenomenon will occur is one of the biggest secrets of astronomy. Some hypotheses suggest that it may occur soon, while others calculate it in thousands of years. Such uncertainty makes Betelgeuse an intriguing mystery for scientists and astronomers alike. Betelgeuse has been making headlines and capturing the hearts of astronomers worldwide since late 2019 by its sudden and dramatic brightness changes. These changes deviated significantly from its well-established 400-day pulsation cycle, raising new questions regarding its stability. This sudden change prompted a worldwide scientific response, with observatories all over the globe monitoring the star closely. The advent of the James Webb Space Telescope, JWST, with its powerful infrared capabilities has brought a completely new dimension of insight. With its advanced equipment, JWST has provided Betelgeuse's outer layers with unprecedented depth, showing evidence of structural instabilities and possible indications of an impending supernova explosion. Should Betelgeuse explode, the supernova would be observable even during the daytime, producing a light equal to that of the full moon. It would be one of the most wondrous natural events ever witnessed. But as stunning as this sounds, many people have wondered, would such an explosion endanger our planet or solar system? Betelgeuse lies approximately 650 light-years from Earth, close enough to study in detail, but far enough that we're in no immediate danger. Current models suggest the star may only have around 100 to 300 years of nuclear fuel left in its core. Having exhausted the hydrogen to be burned, Betelgeuse has reached its helium burning stage of development, burning helium into carbon and oxygen. This is typical of enormous stars approaching the end of their lives. As it burns the heavier stuff, the star has swelled to enormous proportions. If Betelgeuse were somehow placed in the center of our solar system, its outer atmosphere would extend past Jupiter's orbit, if not Saturn's. Despite its enormity, measuring Betelgeuse has proven to be problematic. The star's atmosphere is complicated and turbulent, and its size changes according to what light wavelength one uses to measure it. Infrared measurements tell us that it's a whole lot bigger than visible light observations imply, so it's a tricky target to define. When Betelgeuse finally runs out of the remaining fuel it has, the fusion process that maintains the star's gargantuan mass will collapse. Without the outward pressure of nuclear fusion anymore, gravity will prevail, and the core will collapse in on itself with unimaginable ferocity. This core collapse would create a neutron star or, more likely, a black hole due to the mass of Betelgeuse. During this apocalypse-like process, the outer regions of the star will be violently flung into space at speeds of up to 25,000 meters per second, releasing an astronomical amount of energy. This supernova explosion would trigger a stellar light display of cosmic scale. To Earthlings, Betelgeuse will be blazing brightly in the sky, maybe at full moon brightness for weeks or even days. It will be both scientifically invaluable and a visual treat, giving astronomers a rare opportunity to witness such a close stellar death in real time. One of the most intriguing mysteries about Betelgeuse in recent years has been its unpredictable and bizarre behavior. Astronomers, in late 2019, observed the star's decreasing brightness as it started to fade more drastically than ever before, and resultant popular belief was a supernova was in the making. The fading was not a mere subtle dip. It was visible to the naked eye, decreasing the brightness of the star by more than half. Initially, hypotheses varied from dust clouds to internal pulsations. But further research showed that Betelgeuse had indeed lost a significant portion of its visible outer layers in a stunning event, possibly a partial surface explosion. This kind of activity had never before been observed in a star like Betelgeuse, adding further levels of sophistication to our knowledge of the demise of a star. Scientists began wondering nervously, was this merely a sensational change in the life of a supergiant, or the opening scene of its final curtain call? Stars, especially variable stars such as Betelgeuse, are prone to wink and blink through internal activity, and Betelgeuse itself has been a long-time monitor of a fairly steady 400-day cycle of brightening and dimming. This rhythm was its hallmark, the type of heavenly heartbeat that gave scientists an evolutionary timeline in which to follow its development. But then, towards the end of 2019, something totally unexpected from Betelgeuse, it completely dropped the trend. Within weeks, it darkened in terms of luminosity, leaving the anticipated behavior in the dust. This dramatic, abrupt departure was the Great Dimming. Gone was the predictability astronomers had come to rely on, provoking a frenzy of observations and theoretical modeling. What could cause so great a star to so suddenly and so deeply decrease in light? An internal instability? A surface collapse? The scientific community scrambled for answers, since if Betelgeuse was straying from its normal patterns, it could be a sign that it was much closer to exploding than previously. Months of speculation and observation came to a head when a team of French astronomers, in conjunction with NASA, combed through data collected from the Hubble Space Telescope and other ground-based telescopes. Their discovery was revolutionary. The Great Dimming resulted from an historic surface mass ejection, SME, a colossal expulsion of gas and star material from Betelgeuse's outer atmosphere. This SME propelled a massive cloud of dust and gas into the interstellar space. As this material moved outward, it briefly absorbed some of Betelgeuse's light, making the star look significantly dimmer. This wasn't just some heavenly event, it was the first direct observation of an ejection by a red supergiant by astronomers. The breakthrough unveiled a new, unseen process in a star's late stages of life. It also helped explain why past hypotheses that came based on internal dimming alone fell apart. The star wasn't fading from the inside. It was covering up using its own outblown matter. To understand the sheer scale of Betelgeuse's surface mass ejection, it's helpful to compare it with solar events we're more familiar with. Our Sun occasionally releases material in the form of coronal mass ejections, CMEs, which can interfere with satellites and power grids on Earth, but they are relatively modest by cosmic standards. In comparison, the Betelgeuse SME was enormous. It shed approximately 400 billion times more material than an ordinary CME. That's an amount of mass so huge it's almost beyond our conception. This cloud was dense and spacious enough to cut off a significant portion of the star's visible light from Earth, causing the dramatic fading we observed during the Great Dimming. The eruption surprised astronomers and even changed our perception of the life cycle of supergiant stars. It suggested that such eruptions on their surfaces on such a large scale could be a part of how supergiants shed mass prior to supernova, an event not so hitherto seen so overtly. The burning question still on everyone's mind is, when will Betelgeuse explode? Could we be fortunate enough, or unfortunate, depending on perspective, to witness this celestial event in our lifetime? Historically, astronomers estimated that Betelgeuse would end its life in a supernova explosion sometime within the next 100,000 years. In the universe's vast timeline, that's like a heartbeat, but for human beings, it's frustratingly out of reach and far away. But the advent of the James Webb Space Telescope has completely changed our capacity to come closer to a better answer. Using its sophisticated infrared imaging, JWST can pierce the dust and gas that shrouds Betelgeuse and monitor even the subtlest changes in temperature and shape. These locations of data are helping scientists hone their models of how stars age, especially for red supergiants of high mass. Even as a precise prediction is elusive, the intense observations pouring in at present suggest the star might be moving into its final stage much faster than was previously believed. A new research by astrophysicist Hideyuki Seo and colleagues at Japan's Tohoku University has sent shockwaves in the world of astronomy. Using sophisticated computer simulations, the researchers examined the internal structure, pulsation properties, and luminosity changes of Betelgeuse with high precision. What they found was alarming. Betelgeuse was possibly already in the late stages of carbon burning, one of the final nuclear burning phases in a supergiant star's evolution. When a star begins to burn carbon in its core, it has only decades, at most a few centuries, before it explodes. If Seo's model is correct, Betelgeuse's blast won't be thousands of years down the road, but rather around the corner, cosmic-wise. This new theory runs counter to past assumptions and has fueled interest in keeping close watch on the star's every move. While it doesn't forecast an imminent supernova, it does raise the very real possibility that Betelgeuse will meet its end well within the next 100 years, at least within the lifespan of people alive today. When a star like Betelgeuse runs out of all the carbon fuel in its core, its fate is sealed. Without fuel to power fusion, the core will collapse rapidly under its own intense gravity. The collapse itself is what triggers the explosive release of energy that is a supernova. Although this final process is inevitable, predicting it exactly is extremely challenging. At this stage in a star's existence, the normal indicators astronomers look for, such as variability in brightness or erratic pulsations, tend to fade or completely disappear. The star begins what has been called by some scientists its quiet phase before its final